just did. I want you to follow along with me as we look at this, okay? So you wrote this in the top left corner. This is your parent graph of a rational function. So we have y equals 1 over x, rational function that graphs as a hyperbola. There's a vertical asymptote at x equals 0, which is this line, and a domain, all real numbers except x equals 0, which we went over yesterday in class. The horizontal asymptote is this. So on your papers, look at this. This is your horizontal asymptote. It's at y equals 0. So the range is all real numbers except y equals 0. Okay, when we're doing these problems, you will need to find the following: holes, vertical asymptotes, and horizontal asymptotes. Steps to finding holes, vertical asymptotes, horizontal asymptotes. You have to first factor the top and the bottom, which is the numerator and the denominator. All right, look at this because this is how you're going to do your homework. Holes. If a factor crosses out on the top and the bottom, there's a hole when you set that factor equal to 0. So you have this function over here that's factored already. We talked about x plus 2's going away. Those would cancel. Therefore, there is a hole at the value that would make that 0. So you set that equal to 0, and x equals negative 2. So there's a hole at x equals negative 2. The vertical asymptote, you factor the denominator and you set the factors equal to 0 and solve for the vertical asymptote. So you're only looking at the bottom, but you have to consider the hole. So if I had this one, the x plus 1's would go away. So you had a hole at x equals negative 1, and there would be a vertical asymptote at this second one. Are there any questions on that? Brianna? No. The hole is always the one that crosses out. So if neither one of them cross out, then no holes. That's a hole. Okay? That's right. Now, the horizontal asymptote, there's 3 options here. You need to compare the largest exponents, and we just went over this. If you look at this function, you look at the biggest exponent. So this exponent is the biggest on the bottom. So bigger on bottom means 0 as is the horizontal asymptote. Y equals 0. Remember, y equals 0 is, look at my hands, y equals 0 is a horizontal line. X equals 0 is this. So this is your verticals, this is your horizontal. The next one is bigger on the top. There's no horizontal asymptote. So if I have a 5 exponent on the top and a 2 exponent on the bottom, there's no horizontal asymptote. And then the last one, exponents are the same, divide coefficients. So you have 2 and 2 as your biggest exponents. Those are the same. So you take the coefficients off of those, which is 3 and 5. Any questions? All right, let's do an example. Uh-oh. That's the example. Write that down. Write down this part right here.
And which one?
Well, just let me do another one. Sorry. I'm sorry. Hold on. I'm going to show you. Okay, so in this, on your sheet here, I understand. Hold on. Well, a lot. All right, here we go. So in this box right here, okay, in that box right there, we're going to put an example. Okay, so here, this box right here, I want you to put y equals x plus 4 over x squared plus 6x plus 8. Okay, the first step up there at the very top, steps to find these holes, vertical asymptotes and horizontal asymptotes. You factor the top and bottom. So, does the top factor? No. It does not. There's not a squared. It can't. Now, and there's not a GCF, right? Does the bottom factor? Yes. To what? X plus 4, x plus 2. All right, now I have to find holes first. Holes only occur if something crosses out. Does something cross out there? So I set x plus 4 equal to 0, and I solve, which would be x equals negative 4. So there is a hole at x equals negative 4.
How does that make it negative 4?
Because you solve for x, subtract 4 over, so x would equal negative 4. It's because you can't put negative 4 in for that x because you'd have 0 there. Okay? All right, let's do a vertical asymptote. Look at your notes over there. Vertical asymptotes, factor the denominator and set it equal to 0. So what happened to this one? It goes away, so that's not part of it. My vertical asymptote's only going to happen on the ones left. So x plus 2 equals 0. X equals negative 2. Any questions? So where is the vertical asymptote? Yeah. X equals negative 2. Who asked a question? Who asked a question? If you can't, right, there's not a hole if you can't cancel them out. All right, what about horizontal asymptote? That's right. Is it bigger on bottom or bigger on top or the same? Bigger on the bottom, so that's Bobo. So bigger on bottom, 0. Y equals 0. Are you with me? Questions? You have to do all 3 of those. Okay, watch. I'm not going to give you homework, so pay attention for the next 2 minutes, okay? This right here, do you see how that crosses out? Okay, that technically reduces to 1 over x plus 2. Just watch me. Don't write this down. You can write it down tomorrow. Listen. That is going to graph as this. What happened yesterday if I put plus 2 on the bottom? Stop moving. I'm not giving you homework. Don't make me regret that. What did plus 2 on the bottom do? No. It goes left 2. So think about that parent graph. Think about that parent graph. Look at the parent graph. That is going to shift everything over 2. So watch. Instead of an asymptote of x equals 0, I have an asymptote of x equals negative 2. Watch how I draw this, everybody. I also have a horizontal asymptote at y equals 0. You see that? So I'm going to have this because that's how it shifted. Now, I've dealt with the vertical asymptote. I've dealt with the horizontal. What have I not dealt with? The hole. Where does a hole happen? No. No. At -4. So when x equals -4, which would be right here, there is a little jump in that graph, and it's a hole. So there's just one little ordered pair missing. Does that make sense? Tell me what my domain is of this. Right. Except x equals -2 and -4. Stop moving. What's my range? It's all reals.
Except
What can y not equal?
0.
0. And there's one more because of that ordered pair. I'll show you how to find that tomorrow.